Problem 9.67. A Wall Street Journal article suggests that age bias is becoming an even bigger problem in the corporate world. Top executives chase youthful appearance but miss real issue. So that was the article. In this problem, the first sentence is really just a bit of background information. If we keep going, we get the key information that we need. In 2001, an estimated 78% of executives believed that age bias was a serious problem. Okay, so let's look at this sentence in a little bit more detail. 78% of executives believe that age bias was a serious problem. In talking about that percentage, we're giving a proportion. So we haven't used the word proportion, but when I see a percentage, that's my first thought. It is possible to look at an average or a mean of percentages, but in this case, the percentage result is representing the proportion of executives that believe that age bias was a serious problem. So the percentage in this case is in relation to proportions. So straight away, I'm thinking, okay, this problem is going to be a proportions problem. If we keep going, in a 2004 study by ExecuNet, 82% of the executives surveyed considered age bias a serious problem. So we had this initial result back in 2001 where the proportion was 78%, and then in 2004 there was a new study and 82% of the executives surveyed considered age bias a serious problem. The sample size for the 2004 study was not disclosed, but let's suppose that 50 executives were surveyed. Okay, so at this stage I'm thinking, well, I've got two results. There's that initial 2001 result. So given, I'm talking about proportions, I'm thinking that there's going to be some kind of test. The 2001 result is the sort of status quo. It's our starting point. So that 78% is looking like a population result. We haven't said anything about having a survey, just that that's what it was estimated that the proportion was. But then in 2004 we did a survey and got a sample proportion, 82%. We know the sample size, well, we know what we're assuming sample size to be. So let's have a look at part A. At the 5% level of significance, use the 6-step hypothesis testing method to try to prove that the proportion of executives who believe that age bias is a serious problem is higher than the 2001 value of 0.78. So if we were in any doubt about the type of question, we certainly are not once we've read through part A. As soon as I see that level of significance, I'm thinking hypothesis test, but in fact the words hypothesis testing method are included in the next bit of the sentence. So this is a hypothesis test with an alpha of 5%. We're trying to prove that the proportion of executives who believe that age bias is a serious problem is higher than the 2001 value of 0.78. So that 0.78 is our population result. It's our status quo, the starting point. And we're going to use our sample from 2004 as the evidence to see if it's in fact higher than what was estimated back in 2001. The fact that we're talking about wanting to test to see if this proportion is higher in 2004 tells us that this is a one-tail test because direction is important. We're not just seeing if it's different from 78%, we're seeing if it's higher than 78%. So that higher component tells me that my alternative hypothesis is going to be that pi is greater than 0.78, and then I can work backwards to the null, which I know is the complement, and so my null is that pi, population proportion, is less than or equal to 0.78. Remember, the null is the status quo, the starting point. The alternative is the hypothesis of change. So if we're trying to see if it's changed and is now higher, that's what goes in the alternative hypothesis. We had our sample proportion of 82%, so 0.82 is a decimal, and we know our sample size is 50. One-tail test, alpha is 5%. When we're doing a test involving proportions, we can use the normal distribution Z given that it's a one-tailed test, it's just one reject region. So firstly, I'll draw up my decision diagram. You can see we've got our Z diagram. One reject region of 5% in size, so 0.05 is the size of our reject region. It's Z. It's going to be an upper tail reject region because remember, when it's a one-tail test, the reject region goes in the same direction as the alternative hypothesis. So what it's basically saying is the only way we will go against the null, that the true population proportion is less than or equal to 0.78, the only way we go against that is if we get a high sample proportion. And so that means the only way we can reject the null is if our test statistic is up in the upper tail area. So we've got that upper tail reject region. We know the reject region is 5%. Use the inverse Z table, look up the cutoff point, and it's 1.6449, which we can round off to 1.645. So we've got our decision diagram. Now all we have to do is look at the test statistic. The test statistic when we're doing one population test for proportions is just sample proportion P minus population proportion pi divided by the standard error, which in this case is the square root of pi times 1 minus pi divided by n. We've got all the information we need. We know our sample proportion, 0.82. We know the value for n, 50. And we know pi because remember, when we do a hypothesis test, we always proceed on the basis that the null is true. And so that means we're going to be substituting in pi equal to 0.78. That's our null hypothesis. So put in a p of 0.82, pi of 0.78, and an n of 50. And you can see we've got the test statistic. So all you need to then do is put that into your calculator. It's probably a good idea to work out the standard error component first. So the 0.78 times 1 minus 0.78 divided by 50, then take the square root, get that first, then you can finish off the calculation, and we end up with a test statistic of 0.68. Now, if we compare that test statistic to our decision diagram on the left, we can see that 0.68 is clearly in the non-reject region. The reject region only starts at positive 1.645. So because our test statistic is below that, it's in the non-reject region. So we don't reject the null at 5%. And we can say there's not enough evidence to support the alternative hypothesis. And of course, the alternative hypothesis was that the proportion is greater than 78%. So even though our sample proportion is a little bit higher, it appears on the basis of this test that it's just part of natural sampling variation. So not enough evidence to go against the null.